Hey guys, good to be with you again. Good to be talking to you guys. Hope you guys are doing well. We're going to be talking about molarity today, and one thing that I noticed from the notes is just that I forgot to give you guys the definition of molarity, so we're going to do that real quick. Molarity is a unit of concentration for a solution that tells the number of moles per unit of volume. And so that's going to end up being in the unit of moles per liter or molar, shown as a capital M. Either way work just the same. And why that's so important is if you've noticed in our labs, usually we aren't dealing with just a solid. Usually we're actually dealing with some substance that we've dissolved in water. And so for us to be able to do reactions and things like that, having a unit to be able to track how many moles are in that solution is really, really helpful. So that's why this is such a big deal as we are dealing with chemistry. So with that, we'll look at objective. We need to be able to calculate moles, liters of solution, or molarity, given the other two in the molarity formula. Well, you guys know where to look for formulas. So if you look on the back of that reference sheet for formulas, you'll see that molarity, again, abbreviated as a capital M, and that is equal to moles of solute divided by your liters of solution. Okay, again, that's on the back of your periodic table. That's given to you. It's not anything that you have to memorize or anything like that. Now, the big thing, just like all of our other formulas that we're going to need to pay attention to, is as we're going through these, sometimes we're going to be given information that isn't exactly one of these values, and we need to convert it into this unit. So for example, we might be given grams of solute, and we have to convert it to moles of solute before we can plug it in. Or we might be given milliliters of solution, and we have to convert it to liters of solution before we can plug it in. So again, I'll show you examples of those and how to work with that. So before we get there, though, there are a couple of terms that we're going to need to kind of flesh out. We've got solute. Solute is dissolved in another substance. So whatever you have dissolved in a substance, that's going to be a solute. And if we're thinking about something that we deal with on a regular basis, then that's going to be, if we're looking at, let's say, some sweet tea, right? And I know the color is not going to be great, but we've got some sweet tea here. And to make it sweet, we've got to put some sugar in there. Well, once we have that sugar dissolved, this right here is going to become our solute, because it is what got dissolved into that water, okay, into that tea. So the sugar is going to be your solute. Then we've got solvent, which is what's doing the dissolving. So the solvent is dissolving the solute. If we go back to the sweet tea example, we're going to have the water that dissolved all of the tea, all of the ingredients in the tea, all of the sugar, so that water is actually going to be what the solvent is in this case, because the water does the dissolving. Most of the time, water is going to be your solvent, just because most of the time that's what we dissolve things in. And the way I remember the difference between solute and solvent is solute sounds like the word salute to me, and so I think to like our armed forces, and the one that salutes the other people, like the ones that are going to salute the officers, are going to be whoever is lower in rank. So to me that makes sense with, the one being dissolved, that's the smaller one, is going to be solute or saluting. So that's how I remember the difference between solute and solvent. Then the last one is solution, which we've talked about in passing a couple of times, but here's where we get really official with it. We've got a homogeneous mixture, uniform throughout the mixture. And so solution is just really a synonym for the word homogeneous mixture. And so if we are looking at the sweet tea, then that's going to be the whole mixture here. So sweet tea would be our solution. Okay. And again, if you have any questions about any of this, just post those questions to the assignment. I'll get to you guys and try to help you guys out as best I can. So then, the first example there, we've got what is the molarity of a solution if we dissolve 3.5 moles of sodium chloride in 1.5 liters of solution. So again, this is where we're tying a lot of things that we've done already together. So first we see that we've got molarity is what our question is asking us for. We want 3.5 moles of sodium chloride and 1.5 liters of solution. So one thing that we're going to pull out is that we need to know what is that sodium chloride. So I'm going to do a quick side work here. So I've got sodium is Na, and I know that Cl is chloride, and I see that that's an ionic bond, so I know I need to show my charges so that I can get subscripts. So Na is a +1 charge. Cl, it has 7 valence electrons. It wants to get to 8, so it's a -1 charge. So that means that my formula is going to be NaCl. So that's what my sodium chloride is as I'm looking at that. Then, like we always do, pull out all of our givens. So I've got molarity, that's what I'm looking for, moles. I've got 3.5 moles NaCl, much faster than writing sodium chloride out, and then also helps us if we needed to convert from a mass. Liters, we were given 1.5 liters of solution. And then again, formula is molarity equals moles divided by liters. So check, make sure that everything is in the right units. I've got moles and moles, so we're good there. And I've got liters and liters, so good there. So I can just plug in now. So I've got molarity, I don't have anything for, 3.5 moles of NaCl divided by 1.5 liters. And then I've got molarity is my unknown. It's isolated, nothing else over there. So I get to just do my math out. I've got molarity equals, and I'm going to give you guys just a second to get that calculated out. All right, when you do that, you should get 2.333 moles of NaCl, we can only keep 2 significant digits. Both of our numbers had 2 significant digits, so that's going to be molarity equals 2.3 molar NaCl. Okay. Alright, I'm going to stop this video here. I'm going to have a second video that we'll dive into a couple more that look at you guys being given slightly different givens where you have to maybe do a conversion or something like that. And so that'll be the second video. Thank you guys.